Hi, my name is Aaron Ward, and this is part 2 of my analog input to 7-segment LED project. Since the last time I made a video, a couple things that I've done to improve this is in my code I originally had the enable lines enabled for the LEDs before I sent the data from the PIC over, so anything that was going to those lines was appearing on the LED, so you'd get some really faint flickers on some of the segments that weren't supposed to light up, and therefore you couldn't see a real strong contrast between the on and off. So I just flip-flopped those lines of code, and now I send the whatever digits I want to go to the display before I enable the lines, and therefore I'm not getting any of that soft flicker. So I also decreased the value of my current limiting resistors here, these 7 here, so that I get a brighter display and I have a real strong contrast now. Another thing that I did was, like an idiot, I had originally right justified my 2-byte result from my analog to digital conversion in the PIC chip, and this is a 10-bit conversion in the PIC 16F684, and I cut off the top 2, or the most significant bits, which is why it was jumping around a lot in the old version. So I've since left justified that result, and then used the 8 most significant bits, which now I'm not chopping off most of my result, the most significant part. So I also changed the values of some of my delays and the ratio between my display time to sample time. And here I'll show you, as I turn the potentiometer here, you'll see that I get a very smooth real-time change in my values, and I'll turn it all the way down to 0, and you can see that I can turn it and get a full range of 0 to 100 now. Now a couple other things that I changed in here was, here, let's just set it at some arbitrary value there. Right here is where my voltage divider comes in for my analog to digital input. You can see the red wire is the top of the potentiometer, then the brown wire is the wiper, and this green wire is the bottom of the potentiometer. So before I had a 10 kilo ohm resistor, fixed resistor, in series with this 5 kilo ohm pot, and therefore even if I had this pot turned all the way up to 5 kilo ohms, I was only getting 5 divided by the total, 5 plus 10, so I was getting 1/3, 5 out of 15K, of the values of my analog to digital input. I've got a 5-volt reference, so I changed that to where now the 5 volts is only across this potentiometer, and the wiper is somewhere between the 0 and the full 5 volts, so I get the full range. Another thing I did was I scaled this value, so instead of outputting 0 to 255 bits of resolution, since I'm only using 8 of those 10 bits, now I scaled it to 0 to 100, and the way I did that was, in my code, I multiplied the value, the binary value, by 100 over 256, and or if you reduce that, 25 over 64. Now in a higher level language, such as BASIC or C language, I could have done that multiplication in like one line of code. But I've got 3 pages of assembly code here that does this conversion and display. And let me see if I can back this up far enough. I've got from here to here, all this code just multiplies by 25 and divides by 64. It's about 40 lines of code there, maybe 42. And now even in C or BASIC, all that code is required, but it's done for you by the compiler. So, but I've written that code in assembly, so I do it myself. And my friend Bill came over a few days ago, and he helped me. We troubleshot this little circuit and fixed the code, and now it works very well. So I've got an analog input, this potentiometer, and a digital readout over here in decimal. I still haven't done the leading zero suppression, but I'll get around to that soon enough. Another thing I'm going to do, as I said last time, is I'm going to get rid of this BCD to 7 segment decoder hidden under all these wires here, and the inverters, by putting a lookup table inside my PIC chip to do those conversions in code. And then I'll only require the one chip, the PIC chip, to drive the 7 segment LEDs. Now you might be asking, well, what's the good of all this? Well, now I can use this analog input and digital readout to control something like a stepper motor or a servo motor or even a DC motor, or any kind of output that I want to scale or I want to control with values of really, it's still in code, it's 256 values, but I've output here 0 to 100 because that's more intuitively easy to understand for humans who work with 10-based decimal numbers. And then, of course, this is the stepper motor I'm planning to use for a test. I pulled this out of an old printer or a scanner or something, and as you can see, as this stepper motor turns, it'll have to turn many times because it's geared down to get a fine resolution on this belt that it pulls on a pulley system. And so the stepper motor will have to turn many times to get this belt to move just a little bit. And so I'm going to have to scale the value that the stepping sequence that comes out to the stepper motor, so that maybe for every bit of resolution in the PIC chip, 256 values, this thing might move 30 or 40 or 50 steps. So that's what I have right now. If you have any questions, want to know more about this, or want the code, or you want to learn about PIC chips, just write to me at samuelarronward@gmail.com. Thanks for watching.